Problem 2352 asks us to synthesize this, or the version with the chlorine at the meta position to this group, using only benzene and 1-butanol as our source of starting carbons. So we want to identify which types of pieces we see in this product and where we can get those pieces. Hopefully it's relatively obvious that we get the aromatic ring from the benzene. We also can see a chain of 4 carbons here and a chain of 4 carbons here. Joining those 2 carbons together is an alkene, which should be a pretty good indicator to us that we have a Wittig type reaction. So one of the things that we're going to do with alcohol is make a Wittig reagent. So we'll talk about those conditions first. The other type of condition that we're going to make is trying to join this 4 carbon piece on, so we'll need to make an acyl group. We'll talk about that as well. And then the only difference between A and B in this problem is which order we add the chlorine on relative to the other groups. So we'll talk through that as well. So the first step here is to make a Wittig reagent. We're going to take the alcohol and we need to convert it to some sort of halogen. I'm going to use PBr3 and use that to create the bromide version of that 4 carbon chain. Once we've done that, we can react first with triphenylphosphine and then with N-butyl lithium to create the Wittig reagent. So we'd have the triphenylphosphine and then the 4 carbons as a Wittig reagent. We can use this to react with any sort of carbonyl and create this double bond that we see. So again, just in case you can't see that with the light glare. Okay, the next thing that we need to do is make an acyl group to install these 4 carbons in the first place. To make an acyl group, we need to oxidize this. Any sort of oxidant would be fine because this is a very simple molecule. I'm going to use KMNO4 and hydroxide. I'm going to follow that with acid workup. That will give me a carboxylic acid. That carboxylic acid isn't actually going to be what we can react with the ring. We need some sort of acyl chloride in most cases. So I can accomplish that by using SOCl2. And now we have the acyl chloride. So we can add this to the ring with aluminum trichloride. We can react this with that to make this group. And we can add the chlorine with FeCl3. The question now is, what order do we have to do those? So if we want to make sure that the chlorine is at the para position as shown, we want to make sure that we have a para director for this, or that we install the chlorine first. Really, either is fine. So we can install the chlorine first using chlorine, Cl2, and FeCl3. The chlorine is an orthopara director. That's one way of doing that, and we can install this this 4-chain group using this and aluminum chloride. That will give us this with a double bond to oxygen on the top, and reacting with the Wittig reagent will give us the final product. That would work just fine. You could also do this first with the aromatic, then react it with this to form this part of the ring, and then chlorinate after that, because this would be an orthopara director as well. Both of those would work just fine. If you want to do 52B, now the chlorine is actually at this other location. So 52B, we have the chlorine at this location instead. And now we can't install the chlorine first. We need to first acylate. The acyl group is a meta director, so then we can install the chlorine and we can do the Wittig reagent afterwards, because if we do the Wittig before, this turns from being the carbonyl, which is meta directing, to being this alkene, which is orthopara directing. So we need to do this first, then the chlorination, then the Wittig reagent in 52B.